Right. In this chapter, we are going to talk about the types of system of linear equation and matrices. So basically, we are going to learn what are the types of the solutions of system of linear equation, and also how do we use the matrix to actually solve the system of linear equation. Right. So the objective of this chapter, right, is to introduce the types of system of linear equation, right? So it will be the types, right, of system of linear equation. So you need to know how to identify the different types of the solution of a system of linear equation. And after that, right, we are going to learn about matrix. So you need to know the different types of matrix and how to perform the operation on matrix. Now the operation here means that plus, minus, multiply, all right, and also, all right, divide, right? But in matrix, we do not call it divide. We have a separate concept here. Right, now the last two sections, you need to know how to write a system of linear equation in matrix form, and after that, you need to know how to solve, right, the system of linear equation by using the inverse matrix method. All right, so these are the things you should know after this chapter. So we are going to start with the first uh, section. Right, the first section is, right, we are going to know the types of system of linear equation. All right, now in the previous discussion, we already know that, right, if we solve two simultaneous linear equations, all right, so we solve two linear equations simultaneously, so we actually can find a solution which represent the intersection point, all right? And we also talk about two types of real life situation, which is the break-even point. So the break-even point is actually for the um, business, okay? And the equilibrium point is for supply and demand, and this is in the area of economics, all right? So let's start with some revision before we continue. All right, now if we have a system of linear equation, all right, it will involve two variable or more variables. All right, so for example here, right, we can see the variable involved are x and y. Right, we have two variables here, and this involves two equations. Now, what is a, b, c, d, h, and k? They are numbers. Okay, so they are numbers. So when we put it like this, right, x and y, they are variable, they are unknowns, right? And a, b, c, d, e, a, b, c, d, h, and k, they are numbers. So when we solve, we can find an intersection point x and y, all right, represent the solution of these two system of linear equation, right? So now basically, there are three types of solution for a system of linear equation, all right? So for the first type here, right, this is the first type. Now for the first type here, right, we call this a unique solution, right? Means that we can get one solution, right? One answer for x and for y. Okay, so what happened to the graph is, right, the line 1 and the line 2, right, this is the line 1, the line 2, they intersect at exactly one point. So this is the intersection point, all right? So at this point, right, the x for line 1 is the x for line 2, same as the x for line 2. The y for line 1, same as the y for the line 2. Right, so this is the intersection point. So we have exactly one answer, x and y. One answer only. In this case, we call this unique solution. All right, now let's look at the second situation here, the second types of solution of a system of linear equation. Now, it might happen that, right, the line 1 and line 2, they are parallel and coincident. Now, what does it mean by parallel and coincident? It means that the two lines, they actually overlap each other. Okay, so the two lines, right, overlap each other. So if we look at the lines from the graph, we can see it look like one line only. Okay, now for this system of linear equation, right, or for these two lines, how many intersection points? Right, how many intersection points? Now we can see that each point, every point is a intersection point, right? So every point is an intersection point. Therefore, we have many solutions, right? Remember, the intersection point is the solution. So if we have one intersection point, we have one solution. But for the second situation here, we have many intersection points. So we say that, right, we have infinitely many solutions. So every point is a possible solution. All right. So the second situation, now when we have when we have two lines, they are parallel and coincident. So we say that the system has infinitely many solutions. Okay, let's look at the third situation here. Now the third situation here, we can see the two lines, they are parallel, but they are distinct. All right, so now if they are parallel and distinct, what happens is that, all right, they are parallel, all right, but they are actually two different lines. So for this system, is there any intersection point? Okay, from the graph, we can see, right, there are no intersection point. All right, so no intersection point. So we say no solutions. All right, so for the third situation, all right, it has no solution. Okay, now how do we know whether a system of linear equation, all right, they are the type 1, one solution, or type 2, infinitely many solutions, or type 3, right, no solutions, right? So we are going to look at the m, the slope, and the c, the y-intercept, right? The slope and the y-intercept tell us many information. One of the information is that, right, the slope and the intersection can tell us whether, right, the system of linear equation has unique solution, infinitely many solutions, or no solution. Right, let's start with this one by one. Now, for the first one, right, the first situation, now from the graph we can see the slope for the line 1 and the slope for the line 2, are they equal? All right, obviously they are not equal. So, right, the slope for line 1 and the slope for line 2, right, they are not equal. Okay, now how about the y-intercept? is the y-intercept for line 1 and the y-intercept for line 2 equal? No. So we say C1 and C2, they are not equal as well. So when we see this situation, different slope, different y-intercept, then we know the system has one unique solution. Okay, now let's look at the second situation here. Now the second situation, all right, we know that the two lines, they are actually parallel and coincident. All right, so they overlap each other. So what happened to the slope? Do you think the slope is the same? All right, yes, the slope is the same. All right, m1 is equals to m2. Right, for these two lines, they have the same slope. Now, what about the y-intercept here? All right, do you think these two lines have the same slope, identical y-intercept? Yes, right. We can see it's the same point. Therefore, the y-intercept for line 1 and the y-intercept for line 2, they are equal as well. So when we see this situation, then we know, right, the two lines, they are parallel and coincident. Therefore, all right, they have infinitely many solutions. Okay, and the third situation, right, let's consider the slope, right, m1 and m2. Now, since they are parallel, now what happened to the slope? Right, the slope should be equal. Right, let's consider the y-intercept. Now, this is the y-intercept for line 1, and this is the y-intercept for line 2. All right, C1, C2. So, from the graph, do you think the C1 and C2, they are same point? No, they are not the same. All right, therefore, if from the system of linear equation, we can see the slopes are equal, but the y-intercept, they are different. Therefore, we know line 1 and line 2, they are parallel and distinct, and the system has no solution. Okay, so for unique solution, the slopes are different, y-intercepts are different. For infinitely many solutions, the slope are equal, the y-intercept are equal. And for no solution, the slope are equal, the y-intercepts are different. Right, so this is how we identify the types of solutions of a system of linear equations.